Hello, today's activity is from Lesson 2-1 on terminating and repeating decimals. First, you have two vocabulary terms that I'd like for you to put in your notebook. So if you want to pause the video now and put terminating decimal with the definition and two examples, and repeating decimal definition and two examples into your notebook, and then start the video again. So first we have terminating decimal. So the root word for terminating would be terminate. Terminate means to end. So these are the decimals that you're most familiar with. For instance, 0.5. There's no dots at the end. There's no bar on top. So it ends at 0.5. Here's another one, 4.12. There could be multiple numbers past that. It could be a really long decimal, but as long as it eventually ends, then it's called a terminating decimal. Then we have repeating decimals, which is what we're going to be working with a little bit extra today. And that's when you have a number or a pattern of numbers that repeats. And you use something called bar notation. I think you've seen this before. But whenever you have a bar over the 3, that means that if you were to rewrite this, it would be 3s forever. Same thing here. We have the bar over the 2 and the 9. So if we were going to rewrite that, we would repeat the 29 over and over and over again. So those are your examples with the definitions. Now we're going to go and do some examples together. How do you change a fraction to a decimal? So we're going to take the numerator, which is 5, and divide it by the denominator, which is 8. So the denominator into the numerator. So 8 will not go into 5, obviously, so that's a 0. And you add your decimal point. This is going back a little ways in your brain. 8 will go into 50. How many times? 6 times. 6 times 8 is 48. Bring down the 2, add another 0. 8 goes into 20 2 times. 2 times 8 is 16. Subtract, and you have a 4. We brought that one down. Now we're going to bring this one down. 40. 8 goes into 40 5 times, which is 40, and you have no remainder. So the decimal for 5/8 is 0.625. Get in the habit of putting that 0 in the front just so there's no mistake on what that number is supposed to be, or if it's a decimal or not. So here we have a mixed number, and if we're going to put it into a decimal, we should be able to go ahead and know that a -1 is going to go in the front. So we're going to do 2/3 and change it to the decimal. So we're going to do, again, the denominator into the numerator. So I'm going to go over here a little bit. 3 goes into 2. Obviously 0 times. So we're going to add our decimal. 3 goes into 20 6 times. That's 18. That's a 2 again. Another 0. Here we have 2 again. Another 6. 18. 2 again. So you should start to notice a pattern. We're going to have 20 with 3 going to 20 forever, and it's never going to stop. You're always going to have that remainder. So that's when we put the bar over it. And so I'm going to go back over here. Let's put the -1 in the front. 0.6 with a bar over it. The 6 is the repeating. So now here's something a little different. We have a repeating decimal. It would be 0.5555555 forever, but we can change that to a fraction. Now, there is an algebraic way for me to show that to you. However, it is super confusing and hard to comprehend, and so I'm going to show you the rule that works with this instead. Anytime you have something repeating, we're going to look at the number that's repeating, and that's one number, the number 5. So we're going to put the 5 is the numerator in your fraction. Always the denominator is a 9, and it's how many numbers repeated. So only one number repeated, which was a 5. So your fraction for 0.5 repeating is 5/9. So to make sure that you understand the the 9 part, we're going to look at this mixed number. So this one's a little different because we have how many numbers repeating? 2, the number 18. So we have the -2, that's your base number or your whole number, and then we're going to have our fraction. So this number is the numerator, 18, and then on the denominator, it's not just 9. Since we have 2 numbers up here, it's actually going to be 99. Same thing would happen, just for an extra example, if you had 3.729 and you had a bar over the 729, then you should probably be able to guess that our 3 is our whole number. The 729, everything that's under this bar is your numerator, and then that many 9s are under it. Now, sometimes those can be reduced, but most of the time it's okay to leave it as that many 9s. So I hope this helps with looking at fractions to decimals and then types of decimals, your terminating, and then your repeating.